It's M1 Pro MacBook City in here. We have an A2485 that has, you know, all the liquid damage. This has already been cleaned off with some alcohol. We like peeled up the stickers just to get a better look at it. I think our primary danger zones are going to be here and here. Those with a keen eye among you might notice a very significant problem right there. We'll come back to that later. Rest of the board, yeah, fine. I think this had like coffee spilled on it. We could see like, you know, something, a sticky brown residue on the keyboard. Hopefully coffee. Almost certainly though. Probably like a medium roast. And we also kind of, yeah, a little bit of a mess over here. Nothing really that worries me though. I actually don't know what this board's doing on the USB-C connector, but I see some stuff that's obviously bad and obvious problems, and we know it doesn't turn on. So I'm just going to start replacing stuff, and we'll see what happens. We're going to see some mess over here too. Probably toss us in the ultrasonic, I think. But like this stuff right here, for example, this doesn't worry me too much. We're going to ultrasonic the whole board. Our main thing here, and something that's kind of a little bit of a weird issue, is we have an open line. So we can look at our schematic, and we are right here on this resistor. Now we see this little X symbol here. This is a via through the board. So this goes to this, and then it runs through this trace to this test pad, and then connects to PP bus AON. And this is like signals from our PMU to like, hey, turn on. Then it goes to this, and then this. I'm probably going to replace both of these resistors because they look pretty unhappy, but we can see that our trace has exploded. We don't have a test point there. So right now, this is, you're supposed to take these signals and take them to PP bus AON, or PP bus AON is probably a supply for this actually. But it can't get to this right now because the wire's severed. So we could, you can see this little tiny via. That's actually the wire that goes through the board and then, connects to other stuff. We could try to run a wire just to that via, but it's electricity. It doesn't really, there's some cases where it might matter. In this case, it's not going to matter. We're just going to take a wire from the end of this resistor, and then we're substituting this via wire, and we're just going to run it onto PP bus AON, wherever's easiest, maybe here, probably over here. We got some larger stuff here. I'll probably run it to like this capacitor, let's say. Because if it's connected to the line somewhere, it's connected to it everywhere. It doesn't really matter that it's going in right here on this via, or this case, at least in this case. There's other sort of kind of edge scenarios where it might matter where you're putting this stuff. I think just a few of the caps in this area don't look too happy either. We might just swap those out. And then otherwise, we got like a current sense resistor over here, some kind of MOSFET, a few other test points that look pretty unhappy. What are we looking at right here? Yeah, some other stuff for PP bus AON. Like, I think we're just going to kind of swap out these guys. Probably try to just reflow in this area. I see a little resistor right here. It looks pretty corroded. I think we'll replace that guy. I see this cap right here looks pretty unhappy. And then this stuff, nothing too crazy, but we know what to look for. So let's get these resistors off and get new ones on. I do just have a donor, so I can pull from the same spot on another board. It makes my life a lot easier. Okay, well, let's see. Get some gloves on. Let's see. I'm gonna use my flux as like a marker of points to return to. I know I want to get this stuff off. I know I want to reflow stuff over here. And if we saw anything else that looked terribly fishy. We'll come back to that later. I think we'll do this for now, then ultrasonic it and see what it does. I don't want to just replace a bunch of stuff randomly for the sake of it. It's a big way to waste a bunch of time. Oh, that's kind of, I think actually those resistors are fine. We just need to run that wire for the via. Current sense resistor looks like it's like popped in the corner. And all the coffee. Get that cleaned. Yeah, that upper chip looks fine. We'll still just grab one from a donor. I want to get a better look at this guy right there. Like this cap, like this shielding on one end is just gone. Let's get this off. Come on, buddy. A lot of these caps we're removing, they very well might be fine. They just don't look too happy, and it might cause a problem later. And I don't want this to come back to my office in a few months and have to take it all apart again and do all this again. And this just takes, really a few seconds once I'm already in there. So I'll just get off all these guys too. Yeah, look at that. That pad right there is just gone. You can just see that oxidation on the pad is just charred. Probably will actually take more of these. Oh yeah. Seeing this makes me think I probably will take off that resistor. Both of these. Not looking too happy. That one might have been fun. We don't know, so we're just gonna replace them. They don't look too hot. But that sort of thing is like, if you remove, that's kind of what you're looking for when you're looking for like these charred resistors causing like an open line. The pad on them is going to look like these, where it's just totally charred off. There probably is, we see when we scrape it a little bit, we can kind of see some semblance of a pad underneath there. This is oxidation. That's generally what's going to cause your kind of open line devices. It's normally liquid damage with some, oxidized resistor. Like this one, for example, right here from the top side doesn't look too hot, but the solder joint looks fine, so I think we're okay. Okay, let's clean this up with the pencil. We'll start swapping stuff over. We want to get new solder on all these pads that look messed up. So we're going to scrape with our micro pencil and ruin our micro pencil tip. It's kind of like you're doing like a scratch and sniff on the oxidized pad. Then we'll take up some stuff here. That pad doesn't look too happy. Okay, a little bit of hot air. Let's get some flux on this. You want to make sure you have, good solder on pads where you're going to put your new parts, else they might just not bond, and then you have open lines under parts that you can't see, and you're gonna have a bad time. Those other pads look fine. They look shiny. We want shiny. We'll go ahead and start swapping parts over. I think I'm going to grab more of these caps off. This just really doesn't look too happy at all. What else do we have here? What are these for? Yeah, 3V8 AON PMU. Let's get these off. That one looks fine. Okay. The same thing here. We'll prep this area, and then it's going to kind of just be, easier for us to pull our parts from our donor, get them on here, and then we'll run that wire once we get everything else swapped out in the area. Okay. Looks good. Got our donor. And I'm going to have this just kind of right here so I can easily bop, see what I'm doing. I'll just kind of go left to right here. I had these two that were kind of stuck together there. Care if these guys are stuck together. No, we don't. Oh, yeah, we do. Now I need to get these resistors. Through. This is indeed a lot harder than it looks, so move that. I'm going to move my donor out of the way for a sec. Get into high zoom mode. Yeah. Okay. Now, I need to get a little wire on the bottom of this resistor and connect it to PP boost. Nice, nice how the board's nice and hot. Like, let's get the other stuff we need. Hey there. Here, bear with me a moment. For just a couple minutes, sorry. I don't know where I think Monse is gonna be back in a second. This is kind of hot. I need to work on it right now. Okay. It's like all of our hot air rework, I hope. And then we're gonna fix that open line for PB bus A01. We'll be back in a moment. Okay, we are back. I had a lot of other things come in, and I had to stop what I was doing. We have all of our sad looking components swapped out at this point. I still want to, I'll probably run this through the ultrasonic cleaner over the weekends. I won't be in for a few days. But let's run our wire over, and I think we can run power into this and see if it gets our 20 volts and draws some current. Seems like it's turning on. Then we'll just run this whole thing through the ultrasonic cleaner after, because there's just quite a mess over the middle of the board. So we're gonna dunk the whole thing, get it cleaned off. You know what? I feel like this could use some. This one didn't look as bad, but I think probably wouldn't hurt to reflow that a bit just to get it clean. What are we doing? Wire for PP bus AON. If I can find my jumper wire. Oh. Where did I put that bastard thing? There we go. It's right in front of me. Makes sense. This wire might be is this a little big? Ah, that's good. Okay. Let's see, what's our plan here? So we could run it to that. No, what am I looking at? This is this. Is this. Probably this is what we're going to do. Something like this path. I want to get it to right about there. Do about this much wire. I'm going to get a little bit extra. These wires are enameled, so we don't really have to worry about it bridging to other things. We're just going to kind of roughly get it on now, and then after we're done doing the ultrasonic cleaner, we'll kind of cover everything in a conformal coating. But the wire itself actually has like essentially a plastic coating on it, so we're just gonna melt it at the end where we want it to connect to our resistor. Like so. It's going to be long enough to go the other way. I think I'm going to do something like this and kind of path it through here instead. All right, I got that on there. I'm going to grab a second set of tweezers so I can kind of bend this to how I want. Something like this. And now we're just going to double check that we have continuity between our resistor and the wire we just made. So we'll go here and we're good. It's connecting. I'll take the end of this and just kind of wiggle it off. I have that excess. Oh yeah, I did want to just kind of clean this really quick. Actually, let's get a plug on this, I think. And very scatterbrained right now. Flux is good for cleaning, so I just want to kind of warm that up a bit with some flux to clean. I don't think we need to actually fully reflow that. I'm going to get some of this flux off now, just with a Q-tip. Okay, that's good enough. I don't know. We're going to ultrasonic this in a bit to clean off the board more fully. I have a plug somewhere. Let's see what this turns on now. But there are some other kind of problem-looking areas, so not absolutely sure, but we'll see. And we plug in. And we get our initial 5 volts. A little bit of a spike. Okay, so we're still kind of just stuck at 5 volts low current here. Let's check our PP bus voltage. I don't have my my multimeter software on the computer. One moment. This might also just have like a PP bus short. All right, so we got 12.3. You see that current spikes up a little bit to like 0.5 amps. Let's see. That pulsing indicates a short. Get the thermal imager out. Let's see if we just see what our problem is. Well, obviously our board's a little bit warm because we were hot airing it. But okay, well let's just see where our power stop, and that's not really getting us anywhere. Kind of seeing. Let's check our other voltages here. Like 3V8, 5VS2, 3V3, AON, etc. These on the top, 3.8 volts. So I can see our 3V3S2 cycling down. Let's check our 5VS2. So maybe or this guy up here might be bad. Oh, this is a slightly different board, huh? Do we have like for chance? Let's see here. Pretty stable low voltage. Let's check that for a short. Yeah, it was our little resistor right here. Let's see what this does. Oh, you know, I'm looking at an A2485. I'm looking at an A2485. What's my board number here? It's a little bit off. My donor was exact. The schematic I'm looking at is a lethal bit different. And this should be a 2100 820-02100. Okay, are these different from me? This quite different, actually. We don't like the look of those caps. It's not short. So we saw 3V3S2 is kind of pulsing. I don't think that has a pad underneath it. Let's replace that resistor. Oh yeah, that pad is just totally gone. Okay. My schematic's slightly different than this, even though it's the same board number, which is a little strange. Regardless, donor. This is the same, so let's fix that pad first with the pencil and see. Nope. I need a jumper too. It does look pretty bad. See if we can just get by with. Oh yeah, we can just scrape that. Okay. Let's get a little bit more solder on that. Okay. Let's get our new resistor. I can just tell that that's an open line. I'm not, I'm a little bit confused still on why my board view doesn't match up exactly. Yeah, these are all like 3v8 power enable. Strange. Must be different revisions of it. The same board number. Oh well. You can tell that that resistor was not going to what it needed to go to. So probably it. Was it our third one down? Let this cool down for a moment. We'll run power through it. We'll clean it while it's warm. Oh, you know what? I forgot about these guys. What's going on right here? Oh, it's just VBAT. Sure, these don't look super happy though. I maybe do want to just swap these later, perhaps. I know that that's not what's causing our device to not turn on. Okay. Let's see what happens now. Plug it in. I'm gonna get this heatsink off. Maybe thought about these things. Change more stuff. That was my next plan. Okay. Okay. I want to see how these look under. Fine. Maybe you want to just clean this before I look at it more. I'm tired. I've been here all day. Go ahead. Some other things that don't look too happy. It's gone. Okay. We'll find that later. Get the big one off. Where I flung this capacitor. Let's see if we can just find it quickly. On over here. We're kind of just going from issue to issue. We got SSD power rails. Too serious. Oh, let's find that. Okay, so this is the same spec, right? 0.1 UF, 25 volt, 0.1 UF. Okay, so pull that from the donor, which is this guy right here. I might get this donor out of the way. I'll lock in. Lose this part again? Okay. We have maybe other vias missing? I don't think so. Maybe that can't connect right there. That wouldn't make too much sense to me. You know, I don't know which here. It basically seems like our power is stopping at S5 power state, so like 5VS2. We see pulsing on 3V3. I assume there's just some resistor or something somewhere that's not connecting. I'm gonna probably just come back to this another day, get it cleaned off so I can look at it a little bit more clearly, because right now there's kind of a mess on the board and making it difficult on myself. So we'll ultrasonic this on probably next week and look at it a little bit further and see what's misbehaving, causing our not turning on at this point. We already have resolved a few things that would for sure be issues, but wait, there's more. So we'll be back then.
This is I kind of forget what my my last clip on this was. We ultrasonic this yesterday. The board had like coffee spilled on it, and we're kind of near the back area here, like on the back of the CPU, which doesn't bode super well. But we replaced a handful of things in this area right here, and we ran a wire on an open line that was created by a burned out via for, what was this? Let's see. I think just 3V8 AON. Or just to PP bus. Hey, oh, not showing what I'm looking at. Right here. So there is, you know, an interconnect right here, which is that, you know, little test pad that we can see that's kind of burned off. See, I guess my mouse won't show up on the camera, but you know, we see this little guy there burned off. We have a wire now going here. I know that this is touching this, but this wire is insulated. It's not actually electrically touching it. I'll cover this with some glue actually in a second. I think I now feel fine to run power through this. This had a big mess on the board. I didn't want to make it worse. And it looks like there kind of was some crap under the CPU. So I mean, we cleaned off this area, but there probably some coffee got under this chip, and probably the person using this ran power through it. So this might be done, but maybe it'll work now. We placed a good amount of stuff on the back of the board, and I've gotten any, you know, coffee residue corrosion off the board. So we will go ahead and plug it in. See what happens. Got a port on here. Let me open up my USB-C software. Let's see what this does. All right, so 5 volts, 0.01 amps. Let's check the other ports and see what's going on. I want to see if the other ports are doing anything different. I don't think this really had corrosion near the USB-C controller, but ports could have been corroded. Let's see. Same sort of thing there. Check our other side. Okay, I would say we see identical behavior on all the ports, functionally. I think let's look a little bit closer on the back side of the board again. See what we see, as this area was kind of really looked like our problem area. Take a little bit of flux residue. What else did we see? I remember we replaced some stuff right here. Perhaps like one of these guys, maybe. It's like a battery charging IC. I don't think we had corrosion near the inner cell. Actually, might look back. I haven't worked on this for a little bit now. Getting another board done. I might go ahead and just take this off, actually. Let's see what this looks like. Oh my. Oh my god, I thought that the thermal residue was corrosion for a second. I'm like, oh, fuck this. Okay, so there's something, I think. That's just maybe like adhesive residue. What is that? Yeah, it's just glue. I think this is just kind of some like staining from the ISO to clean it. Yeah, I don't see anything here that really looks terribly concerning. Well, let's use our brains to find what's failing. I am just going to ultrasonic this again later. Just going to plate back on for a second. Probably just going to ultrasonic this whole board again, honestly. This one was really messy. Let's see what voltages we have on things. We might just have like a 3V8 AON short. I think is somewhat likely. If I already checked for that or not. I don't think it was short. Okay.
Get on my multimeter.
I'm like slightly disappointed in this Siglet software. Will we detect my... It runs shockingly, slow to update. Like I do this and I have to wait like, half a second and it makes me sad. Okay. First off, right, so we already have our Type-C plugged in. We're doing 5 volts low current. Our PP bus voltage. Quite low. 300 milliamps. We just have a short in PP bus. Okay, well, no short on PP bus. Check. Let's check our 3V8. Where's a nice spot to check this? Sure. I think I'm just going to look. I mean, we have like no low voltage on PP bus AON. I'm just going to check for shorts on a few lines. Mm-hmm. 1000 ohms, 3. That is a candidate. That is in our area that was corroded. I'm just going to flip over the board, perhaps. 5VS2. I think we probably more just have an open line problem, but some other resistor or some chip in this area that's just causing PP bus to like not go active mode. Where's 5VS2? Perchance is oriented differently. I'll find something that looks the same. Okay, we can check right here. Okay, so no shorts on like our usual suspects lines. I'm gonna go look back on the earlier recording I did to see what I've replaced and refresh my memory. I have a vague idea and I can tell some things, but let's just kind of look. Let's use our eyes for a second. That looks like it might be. Fine, just a diode mode. Do we have any open lines? Yeah. So maybe not doing what it's supposed to. How's this? Even reading is short. That doesn't make sense. I'll probably just reference that on a donor. That might just be ground and it's being called something else, but it's just not labeled correctly on the board view. Okay, well, I'm probably just going to keep looking until I find something interesting and then I'll come back.
All right, so we're still just getting 5 volts and low current on all the ports on this board. Well, we ran a wire over here, replaced a bunch of crap that looked bad. And now we are thinking, I'm kind of thinking I do just want to replace this MOSFET on the battery. It looks like it's kind of been through some shit. So let's get this off. And these other two little capacitors for this AON charger. I just don't really trust them. Let's get these off. Okay. All right, so basically what I'm seeing is our power stops at 3V3 AON. We have 3V8, we have PP bus AON, 1V8, no 3V3. I think I'm just going to replace this guy and see what happens. Maybe a few more things just in this area. A little bit of a loss. We don't have any short circuits, so I assume some chip is not doing its job. Just creating 3v3. Let's just do. So 3 of these just apply to this chip, so that's probably not it. Now, where is this coming from? That's probably just sourced from the PMU. We did have a lot of fucking liquid damage, so that is potentially something. Oh, thinking. Looking at our donor, looking at the patient. Which I wonder if just the positioning of that wire is actually what's causing our problem. Maybe that's actually messing up timings. Like 12.3, I think, on here. I guess they want to be too hard to just get onto the VIA. Let's do that. See what happens. Just roll it out. Scalpel. Scalpel. Micro pencil. Okay, so no, oh, I don't have my USB-C showing. No difference. That's what we were getting before. We got 12.3. Okay, well, whatever. That's kind of cleaner routing for the wire anyway. So, just don't know. I didn't do that in the first place. Try thermal camera cheese. Maybe anything can give us a hint. I couldn't really find any shorts on anything, so I really do assume we just have some fuck off problem with a chip or resistor or something like that. I didn't really check SSD power lines. The mental fog. I should do have no voltage there. I'm not sure. Alright, so we see this line's pulsing. Is it? Is your bad boy? Is this our naughty boy? Probably not. Normal residue. I'll take off all the stickers. I think I might be overthinking this. To just have coffee spilled on the CPU, it's probably fucked.
Dropping off. My buddy said he called you guys.
All right, well, I'm entering crash out mode, so I think I'm just going to replace this chip and see what happens, because I'm not super sure. This did have corrosion around it, so let's try it. It might be like S2 main is what's causing our problem, or... hard to say. Try this. 1 second. Pretty sure I made a bin called 16 back camera, and it's in there. We'll see. Chance. Nothing different. Alright, well, I'm gonna lock in. We'll see if I can figure it out. Let's see. Why is this even drawing current? Getting actually quite high resistance now on the line. Okay, well, fuck it. Let's replace this thing and see what happens. I'm kind of, at my wit's end with this board at this point. Well, let's see. We're being dumb. Okay, what am I looking at? Right here. And what I'm seeing get hot is this. Is anything even short around this? 220. 3.5 million. 3 million. 37,000. But perhaps our other boy, USB-C port. Oh, what the fuck is this doing? Did sending power into it do something? I'm not even entirely sure. Yeah, let's replace that other thing on the backside. Who the fuck knows what's going on? I'm crashing out, buddy. I'm losing it. Let's try to see what happens. Looks like it's possibly experienced some hardship. Oh, okay. Never mind. What's going on? I am replacing shit at almost random at this point. We replaced so much stuff on this board, and it had a swath of liquid damage. And it doesn't really seem... I assume we probably already resolved short circuits for stuff that we have replaced. Now we maybe have some weird like secondary rail interacting with 5VS2 shorting, or just some resistors open, and for some reason 5VS2 does just draw current when we inject voltage, even if it's not short.
And I was there for like an hour, like, what the going on? I look, I'm like, oh my god, I don't have power.
All right, since I was going a little bit insane on this, I brought my more than a fixed hoodie today to really lock in. I'm going on a trip tomorrow for 4 days, and this person leaves on the 8th, April 2nd. All right, it's another day. I've had dreams about this MacBook, and I brought my more than a fixed hoodie today, so I can be extra serious. Fundamentally, what we're getting here is low voltage on PP5VS2. We tried injecting voltage. I'm seeing some stuff get hot. The resistance is kind of low, but that's probably not it. I think there's probably some resistor or MOSFET or something not working. So we're trying to see, I think, God, what did I see? There was, this thing here. So we have 3V8 AOM, but what I'm seeing is there's this current sense line. So that's what the, I is, symbol for, or letter for current, basically. So you see I send, that's current sense. So maybe we have a current sense resistor or something like that, failing. I'm probably just going to end up replacing more shit in this area that had the primary kind of source of liquid damage. I might also be doing this all for naught, because this did have a copy on the CPU, which does worry me. Basically nothing that hasn't, didn't look obviously bad remains. So everything that's, looks clearly, no good is gone. We can check stuff like, or let me see our, where's 3V8 AON? What was I looking at? Recording something. I wonder if we have this. Probably not this. We don't have. I'm getting like 200 millivolts on that. Oh, let me turn on my multimeter software here. I think what I came to the conclusion of is that I want to replace this chip. Yeah, this is working. Okay, now we can see our multimeter measurements in the bottom right of the screen. Gosh, what was I even looking at? So 5VS2 main. See, we just get kind of this low. I'm getting 89 millivolts. I'm getting somewhere between like 50 to 100-ish millivolts on different spots on the board, which is a fairly good sign. We just have an open line somewhere where we can see stuff like our input here. We're getting 12.3, and then I feel like I'm getting nothing out from this. Here, that's our VDD. That's our input to the chip. Let's look at, our output. Good, nothing, kind of just that like low 70 millivolts. So I'm going to remove this chip and replace it and see if that changes. We've already done remove a thing, replace it, see if that changes a lot on this board. So, but it's the start of the day, so and my patience hasn't worn thin as it is. Oh. Maybe this, maybe something else. Not really seeing anything useful on the thermal camera. We did see some, stuff on the thermal imager. We replaced that and nothing. So it's not like we have a dead short circuit on this either. So I thought maybe we kind of had like a soft short on the line, and that was it. Oh, let's go ahead and remove our bad boy first. Our potentially bad boy. This also might just be a totally fine chip. We'll see. We'll know shortly. I'm getting my worth out of my A2485
donor, or one of the ones I have here, at least. What would be really happy for me is if I take this chip up and there's like a hole burned through the bottom of it, because that would mean this is bad. Looks fine. And we're getting another call. Oh, I wish I just had someone to answer calls for me all day. That would be nice. That doesn't really work in this, in the industry. Okay, let's get this off. Get it on the other one. I feel like I kind of have a bunch of things near my hot air that will get melted. I'm moving. Okay. It's back here. Pin 1's going to be in my upper right. Need to move my hand. Okay. Burning my hand a little. I'm gonna need more. Okay. Gosh, I might just swap out a few other things while the board's warm, to be honest. I'm trying to think what's maybe the most naughty here. Yeah, that's maybe a little bit. Fan. Don't really care too much about that. What is this guy doing? Guy has some stuff for iSense I. I think fuck it. Let's swap this too. Board's warm. Mine as well. If this wasn't liquid damaged, I'd be quite a bit more interested in what specifically is causing the problem here. This is like a case that I will probably never see again. This is basically really bad coffee damage right in the middle of the board with just a bunch of parts that are bad. It's not really like this sort of I'll probably never see a board, you know, with this set of damage again. It would be astronomically unlikely. So if it's just this one or both, but I don't really care. I just want it to work. You know, we'll know something. We'll know something was causing something. And that's okay. You gotta be okay with some unanswered questions. This is a little bit uneven and it's bothering me. A little bit ADD there, but okay, I would say now. Yeah, maybe these guys too, right? I'm already in here. I feel like I saw. What is it? Maybe these two guys. What he's doing? I might just swap these out too. Actually, I can see that pad was a little bit wonky under that. Okay, now let's cool down, and we'll see what it does. At this point, I'm imagining the same thing, because this has been rather misbehaved. Go ahead and desolder the wire I had on 5VS2. It's kind of necessary. Oh, board hot. Okay. All right, so we're gonna let this cool down, and then we'll check it out some more. I actually found something. I didn't really notice this earlier. When the USB-C is on for a while, we'll actually see the amperage pulse up to close to an amp. And I've been sitting here just kind of like this, looking very closely under the thermal imager. I noticed under this, right here, we have this guy. I'm actually not 100% sure what this chip's for. On the schematic, it's a Folga thick stencil. This maybe is what gives the MacBook its thickness. It looks like it's like USB-C attach regulation of some kind. So this is maybe what tells the device, like, hey, my USB-C is attached correctly. So when you you know, flip around the connector, it does something. I'm already kind of in like a fuck it, let's replace it mode. So I think fuck it, let's replace it. See what happens. Is that we have pulsing current makes me think more short, maybe. Powder donair. Let's do we have anything else hiding around this? Let's see what we got. These are all just like what I wonder though is if maybe there's just some other voltage pulsing up. Let me let this plug this in again. We're gonna have to wait a few minutes for it to actually start doing this kind of like amperage pulsing, but looking at this thing up to like a watt now, we are. Yeah, so I can see R1V8 S2 voltage pulses up and then drops down in sync with the amperage change. All right, well, let's see what happens. Let's see what happens. Certainly not seen this chip fail before. But we did have a mess over here, so maybe. I was just checking what we have on the other side of the board. If this works, I'll be so happy. But this could also be a very good example of how a thermal camera control you. Just because something gets hot does not mean that it's bad. And this isn't getting like, you know, if it was getting like 100 degrees Celsius, then yeah, for sure it's a problem. But it's getting to like 30. But it might just be kind of kicking back other voltages. And now you can see the page here is in progress. So this is still like an early revision board view and schematic, which is like we saw some stuff like, you know, the boards we have right here, these capacitors are oriented in a different way. It was one of the main things I noticed. It just happens to be an error. We had some stuff not working. I really assume this is something just for, you know, understanding the orientation of the USB-C connector. All right, well, we're just letting this cool down. We'll see what it does. Keep cooling. Okay, well, we're gonna let this cool down and we'll be right back. All right, so I've moved on to pleaseburring on this board, and I got some help from a friend Inwarp, who's done, you know, a huge contributions to LogiWiki and just the Rare community. Shout out to Inwarp. I think I've already linked to a comment for someone who is in the EU with a MacBook board, but I believe he's located in Hamburg. I'll maybe double check on that and do a correction in the comments, but I'll link to his website down there. He's very, very good at fixing things. And he's a good guy. So we'll put a link in the comments for anyone in Europe. Send your stuff to RipperDoc. He's very good. And what essentially he was saying here, so we've kind of already replaced really anything that looks visually bad. He has seen these before where there's some corrosion in this area, and what will happen, we essentially have a voltage divider here. We're supposed to be getting 2.5 volts here, and then or what's going on right here is PP bus voltage is 12.3. A lot of times when there's corrosion in this area, this stuff's really tiny, and we did already have this trace explode, which probably means something was shorting over here. That 12.3 will short to this 2.5 volt line and actually damage our PMU directly on the opposite side of the board right here. So we can see where this goes here.
VDDHI. And this is kind of like our, telling this to start up from what I understand. Perhaps that's not entirely accurate. But there's a general kind of what we're thinking here. 12 volts over here, touches 2.5 volts, bad. Our PMU right here does not like it and dies. And fundamentally, it's like we have our 3.8 input voltages to this chip, and kind of what we're not getting is outputs from it. So we're going to remove this. I'll pull one from another board. We'll reball it and get it on there. And hopefully this works. And we'll see what happens. And that's kind of the tricky thing on here, right? This had so much water damage on the back side of the board, and this looks absolutely fine. I'm going to get out my little special hook tweezers. Pull this off nicely. I already have my donor nearby to get and swap out. Get our hotter to 430, 120 airflow. Fume extractor on, so we do not get the cancer. Turn this at a bit of an angle so I can grab this with the tweezers a little bit more naturally.
Yeah, I didn't hear all of it. I just came over. Problem is, what? Go back to Earth. No, you go. Yeah, there's still water. Water.
I'm going to kind of warm this up first, and then I'll get the tweezers in position to pull this up straight.
Yeah. Yeah.
They might use different tweezers here. Just kind of. Okay, we probably have enough leaded solder on here at this point. I don't know, I'm using such a small iron on this large chip. I'm gonna get big iron. Yes, I do see the one pad missing. No, it does not matter. It's a no connection. Well, actually, where are we? Ugh. Yeah, still no connection. What we got? 1, 2, 3, 4, 5, 6. This guy right here, no connection. Doesn't go to anything. We do not care about it. It literally does not do anything. I would say this is ready to get a new chip on. So I'm going to grab the donor. I'm going to get the chip off. We'll reball it. Get that puppy on there. This is my donor. I don't care as much about knocking stuff everywhere. Still try to get it off carefully as I can. That's okay. Clip is okay. In my mind, I can never just get these off perfectly on a donor. Okay. I realize I must have been talking to myself for the last few minutes. We just reballed this. I forgot to click start, but you know, you've probably seen a chip be reballed before. We have another video with a PMU replacement. Okay, chip reballed. Looking good. Get our patient board again, get some flux on there, get this sucker on. A little bit of flux on here. We don't really need a lot. Just kind of schmooze it around. Should be fine. Okay. I believe the Apple logo is going to be upwards, but I'm just going to clean off the top of this so I can see. Okay, we're going to be okay with that. Okay, we're going to let this cool down, and then we'll see if this works now. All right, so now we plug in MacBook and it's behaving. We climb up to 20 volts, we're getting some wattages, and my CPU is getting warm. This is turning on now. What a treat. I'm going to ultrasonic this board one more time because there's just so much flux mess on this board, and a lot of things have been replaced. Probably most of the stuff I replaced on the backside after the initial replacement of corroded parts was not necessary. It was almost certainly just this PMU fault. The first PMU I pulled off of one of my donors was bad, which trolled me for a while. So I got another one off of this board, and that works basically. But yeah, that main thing I think to consider here is that we had corrosion in this area where we have 12.5 volts next to 2.5 volts for a PMU enable line. It's quite sensitive and it's very small, so it's pretty easy for some corrosion to build up and send fire hose into bendy straw, which we obviously see a lot in other cases. Not something I've seen before, though. Thank you, InWarp. Again, you're a gentleman and a scholar. We'll get this back together, though, make a backup. Mangle on this was just data recovery, and the rest of the chassis in this device is totally fucked. Screen's bad, keyboard's bad. So we're going to just get this in a chassis, make a backup, and or maybe just do like a cloud backup for the person or something. We'll figure it out. But we'll be back once we have this back together, I suppose. Really, I'm going to have to rig it up on an external display in the back, so I'll try to figure out a way to record. Okay, and then just kind of quick once over here. So we've ultrasonic the board now. We can see this gets all this flux residue and kind of crap off there. I'm just prepping these for the heat sinks to be put back on. We added some more of that like carbon thermal paste from TCR circuit. He'll still be selling thermal paste. I hope so. I don't know where else I'll get these. But yeah, in any case, I'm gonna get the heatsink back on, and then we will reassemble this device. It's kind of the screen connector. This went somewhere else before this. They didn't do any rework on the board. Unfortunately, they cleaned off the whole board, which made this a lot harder than it needed to be, because we kind of had to guess a little bit. We couldn't just immediately see where the liquid damage was. The connector on the camera side of the screen, I mean, the connector here is fine, but it looks like they just like desoldered the you know, the flex end of it, which is really weird. Once I get into the chassis, I'll show that. But yeah, in any case, I'm gonna get this back together, make a backup. We might just get this thing working too, so we might order a screen and a keyboard, maybe just the keyboard. I think if the camera's fine, I probably would recommend against replacing the screen. Parts, you know, $650, $680. So we'll know soon. Let's get it back together and we'll test more. Okay, so just kind of brief look at the chassis. I think the primary thing, a bunch of coffee spilled, you know, through here, through the very middle of the keyboard. And then this thing is like, can I get this in focus? This is burnt, and then someone just like desoldered this connector, just kind of heated it. I don't know why. I will say it does look like coffee got in much more spots on here. I wouldn't be surprised if the screen's bad. Like this might have gotten on the control board, but the angle sensor looks fine. There's a few other spots that look like some coffee got in, but probably stuff like the trackpad and, you know, battery's okay. So we'll see. Get this back together and we'll see what happens. All right, I must formally shame whoever worked on this before me. So, you know, to read it, you know, cleaning off the board, I think that can be chalked up to ignorance. That just kind of makes my life harder. The corrosion's not there, and I have to guess a little bit more where my problems might be. Many missing screws in this chassis. I basically sacrificed a M3 Pro that I have for sale here. I just took a bunch of screws out of it to replace the missing ones in this, because this person goes out of town in a couple of days for a long time. They this and this camera connector for some reason. I really don't know why. Thankfully, the screen is actually okay on this. We'll get it up in a second. All the show put stickers are just kind of gone from this. That doesn't matter all that much. If this came into my shop in the first place, it probably would have just been a board repair and a keyboard, and they would have had a good working MacBook they could keep using. But someone thought they needed to damage a $650 display. A lot of screws for like housing like the MagSafe and these sort of things were missing. So we just replaced all these missing ones. And then I ordered another set to replace the ones I had to pull off of my device that I'm selling. In any case, though, this works now. So that's fun. Let's plug it in. I'll show you. Gosh, this was a fairly arduous board repair. Let me I'll put this here just to cover names. Gosh, I probably spent somewhere between 8 to like 10, 11 hours looking at this computer in total. It's still just our normal rate for a board repair. You can see this works. The main goal of this was data. They're just gonna pick it up and make a backup at home. It does actually basically work fine. Keyboard works, screen works, camera doesn't work, obviously. It does smell a little bit like rancid coffee, so that will probably get worse with time. In this case, this repair is just for data only. That's all we're guaranteeing here. This one's a little bit too bad, I think, to warranty long term. And it does have other problems, like the keyboard is damaged, the camera thing was damaged. There's a few repairs that are kind of being foregone here, which is fine. They just want to get their data. That's okay. I would probably recommend replacing this machine anyway. Hopefully this helps someone. And I think it will, because this is a bit of a goofy problem as far as like our real, well, in any case, it's like there was just a bunch of very clearly bad things over here. We had an open line here on this and this. This will be a hint to me now in the future. If this gets blown like that, well, it probably shorted to this and killed our topside PMU. So that's really what made me chase my tail for a long time, is we had this chip being bad. There was no actual liquid damage around this chip. It was caused by liquid damage on the other side of the board, which sent 12.3 volts into a 2.5 volt line, killed our PMU. And then on top of that, the first PMU I pulled off of a donor board was actually bad. So that must have been why that board was being sold as a not working board. But in any case, we pulled it off of another one, rebuilt it, and that worked. On top of that, we probably replaced about 30 other things back here on the other side of the board. I do have video for all of this process. I'm probably going to end up cutting this down to hopefully less than an hour-long video. I'll probably just fast forward most of the rework sections, but that's kind of the fundamentals of it. Blown line here, a bunch of shit that was very clearly bad. Back here, I replaced a handful of other components, kind of chasing this issue, which was just a PMU fault. But that's pretty much it. A bunch of liquid damage shit over here. I would say if you see liquid damage in this area, you're pretty likely to have killed your topside PMU if you're kind of seeing this, not getting to like any S5 power states, but you have 3V8 AON, you're getting your supply to your PMU and you're not getting outputs on any of these inductors. You're not getting any of your S5 rails. Those signals are generated out from the big PMU over here. And it's probably this that failed. It may be something where it can happen with this top one too. I assume it's less likely. Again, if you're in Europe, send your stuff to Inwarp at the Ripper dock. He does very good work, and he's a really smart guy, and he will not fuck with you. To our European friends out there, if you're in America, send your stuff to me. We'll fix it. Because sometimes you take your stuff and someone they just mess your stuff up. I really wish this came to me first. I think it would have saved me a very big headache. This probably still would have been quite the task to fix, but a lot of variables would have been eliminated. Had someone else not screwed with it before and done some silly shit, and it also would have saved the customer full function on their device. That does kind of bum me out that someone was just doing weird bullshit on the camera connector. That's not good. Don't do that to your customers' devices. Bad. Whoever did this, well, they probably won't see this, but if they do, come on, man, don't do that. Well, this is a pretty precise problem. So I imagine this will actually be helpful to someone. InReP stated there was some sort of page on the Logi wiki for this, but then it kind of disappeared or something like that. So hopefully this can kind of stand to that. But yeah, fundamentally, if you have corrosion in this area, you might have a dead PMU if you're seeing similar behavior to what we were seeing here. We'll see you in the next video. I have a lot of videos to edit, so we'll go. I'm still recording everything. I just haven't taken time to edit and upload these. I'm really rambling. All right. Bye-bye, everyone.